So what we want to do now is have a look at what we call factorial notation. So the idea of factorials is that we're going to use these in the binomial theorem, but we've got to know what they are. Now we have talked about it a little bit in class because you've come across some of these questions in some of the problems for induction where we use factorial notation. So some people in class have had a look and worked it out. The idea of a factorial notation is basically writing some number and multiplying it by the consecutive numbers going down through to 1. So if we've got 5 factorial, then we'd have 5 times 4 times 3 times 2 times 1. And that when you can multiply that gives you 20, 60, 120, and we multiply it out. Now you've got a button on your calculator that's got factorial notation, so find that button because that will save you a lot of work because you don't really want to have to do that multiplication every time. But that's what it means. So n factorial would be n times m minus 1 times m minus 2 down to keep going and end up with 3 times 2 times 1. So whatever n starts off as, and then it starts moving down by one, and we got the product of those numbers there. So if we're looking at some of the ways to simplify these ones, 8 times 7 factorial, well 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. We multiply it by 8, that would be another way of writing 8 factorial. So what we want to do is try and work out all these little tricks as we go through to write 8 times 7 factorial as 8 factorial. So we'll see ones with algebraic in terms with the ends and other algebraic terms later on. So 9 factorial times 9, well 9 can be written as 9 lots of 8 factorial because 9 times 8 times 7 and so on. And then the 9's can cancel here, leaves us 8 factorial. So 9 factorial divided by 8 factorial, again 9 divided times 8 factorial, and we do division, gives us 9. 7 factorial times 6 factorial, and again we can manipulate this any way we like to get 7 factorial times 6 factorial times 6 times 5 factorial, and the 8 factorial is 8 times 7 factorial, so the 7 factorials cancel, the 5 factorials cancel, you get 6 on 8 or 3/4. So it's just that manipulation of all those numbers. 1 over 4 factorial plus 1 over 3 factorial. Well again, add two fractions we need to get a common denominator. So remember that 1 on 4 factorial is 1 on 4 lots of 3 factorial. So the lowest common denominator would be 4 factorial. So again, 4 factorial, 4 lots of 4, multiply the top and bottom here by 4. So that would give you 4 over 4 lots of 3 factorial. 3 factorial, and that would give us the common denominator of 4 factorial. 1 plus 4 gives us 5 over 4 factorial. And then 8 factorial over 7 plus 6 factorial. We'll get a common factor to simplify this. And the denominator would be 6 factorial, leaves us a 7 there, leaves us a 1. The 6 factorial cancels there, because we can have an 8 there, that cancels to give us a 7 factorial, and 7 factorial divided by 6 factorial will give us 7. So again, you can see the same idea, like simplifying algebraic factorial expressions. So n factorial times m plus 1, well again, that would be n factorial's that expression, but n plus 1 would be n plus, in front of that would be an n plus 1 factorial because you're going down by 1 each time. So you can see how that simplifies, a bit like that 9 lots of 8 factorial gave us 9 factorial. N lots of n factorial, well, plus n factorial, factorise your n factorial out, leaves you the n, and factorising n factorial over there gives you 1, which brings us back to what we just had there. So it would be n plus 1 factorial. N plus 1 factorial over n factorial, well we can simplify that to be n plus 1 times n factorial. The common factors cancel, just leaves us n plus 1. And again, it's similar to all the questions we did with the numbers, like 1 over n factorial plus 1 over n plus 1 factorial. So we can start to get a common denominator. And if we can look at it that way, it's probably not the simplest way to do it, because we didn't get the lowest common denominator, but we had to cancel. But that's okay. It got us down to n plus 2 over n plus 1 factorial there. So that's what we're looking at when we're doing factorial questions. So we're looking to simplify where we can and expand to simplify. So n plus 1 factorial, be n plus 1 times n times the n minus 1 factorial. We get down to a cancellation. N factorial over n minus 2. Again, what does n minus n factorial look like? Well, we can expand it like that to cancel the n minus 2. It leaves us n outside of n minus 1 times n minus 3 factorial. So if we understand what the factorials look like, we can start to simplify them down there. So leave you to have a look at these ones, but again, we're just proving it's to make sure we can factorize where we need to, or get a common denominator where we can, and simplify these ones to get what we need. So starting with the left hand side, proving it goes through the right hand side. The same thing, factorizing. Yeah, like a lot of things, if we factorize, it makes life a little bit easier as we go through. So try and factorize before we expand every time. So again, we get a looking to get a common denominator, and this one's a little bit harder because it's a harder common denominator, but that's really one term on from that. So a common denominator, if we multiply this term top and bottom by m minus r plus 1, gives us the m minus r plus 1 factorial on the bottom, and they've got the common term on the top, minus the 1 gives the n minus r over the m minus r plus 1 factorial. So there we go. Try to look to simplify as much as possible by either factorizing. If you can't do that, like we've said before, try and simplify it by by manipulating the terms and getting them expanded out, and start to cancel where you can.